This week's lab will be investigating how the force acting on two charged objects varies with the distance between those two charged objects. So you'll see here a fancy box with two pith balls. So these pith balls are just these small little balls that are coated in a metallic coating so that they are more of a conducting material. And if we zoom in here a little bit, what you'll be able to see is we have the two balls here. So we have the first ball, which is attached to a rod here, and we have a second ball, which is hanging on a string from the top of the box. So you can see I can give it a little bonk, and it's going to swing. Probably shouldn't have done that because that's going to impact how I do this experiment. And what we can see to make measurements is, so we want to know what the location of each ball happens to be. We want to know where is this first ball that we can slide back and forth. So you'll see that we can slide this, and there's a section of a meter stick that we can take a look at. And then you'll also see that we can make a measurement of where the second ball is located. So the first thing we'll be able to do is we'll be able to line up. You can see a little mark here, and the side of the lab has us lining this up around too. And then what we should find is that this ball is lined up with 2 on the meter stick that's at the back of the box. And then as we slide this ball forward, we're going to want to then see how the location of the second ball changes. And you'll see a little mirror in the background so you can see me talking. And the mirror is to help us avoid parallax error when we make a measurement. So if you think about how are you going to measure where this ball is located on the meter stick, you can see where the string or maybe the bottom of the ball lines up, but if I switch this camera left and right, you'll see that the position of the ball changes on the meter stick. Now obviously the ball isn't moving, but my perspective is changing. So what we're going to need to do is we're going to have to line up the ball in front of us with the ball that's in the mirror. So you can see that if I shift this over, all of a sudden the ball behind and the ball in front are going to line up, and that is how we're going to want to take our measurement. So in this video, I'll make sure that the camera is set up so that you'll be able to see these strings and balls match up with each other so that we avoid this so-called parallax error. Now at the moment, nothing's moving around because I haven't generated any charge. I haven't established any charge on these little spheres. So that's the next piece that I need to do. It's time to put some charge on these objects. I take this acrylic rod, take this piece of vinyl, and rub the two of these together. So now the rod should be charged, and I'll touch the rod to the ball. And then I'll bring the ball on the left close to the ball on the right, and at some point there'll be a quick attraction as polarization occurs. And as soon as the two balls touch, some of the charge from the left ball will jump over to the ball on the right. So now they both have the same amount of charge. And so now when I bring the ball on the left closer, the ball on the right is going to feel a repulsion from it. And to magnify this effect a little bit more, I'll add a bit more charge to this ball on the left. And our experiment is going to be to slowly slide the left pith ball closer to the right one. And as the ball on the right feels this force and gets pushed further and further away, we can measure the location of that ball. So we'll measure the location of the ball on the left and the ball on the right. And from these measurements and the force diagram associated with this hanging ball, we'll be able to determine the strength of the force and how that varies with the distance between these two balls. So in the second video, I'm going to go through the mathematical framework that describes this scenario. We're going to look at the force diagram for the hanging ball, and we're going to see how we can determine that the distance that the hanging ball moves from its equilibrium position is actually directly proportional to the strength of the electric force that is acting on that ball. And once we show that relationship, we'll simply just be able to measure how far this ball swings, how far apart these two balls are from each other, and we'll be able to make a graph of force versus distance, or actually that value of x versus distance, and show how Coulomb's law can come from that.